Hey guys, welcome back to the channel and this new tutorial on Pytorch. In previous video, we learned about the concepts of self-attention. In this video, we will solidify that concept and implement it using Pytorch. Okay, so we could split the implementation in five steps. Okay, so the first step is like we create query key and value using vectors like using input vectors, and then we compute attention scores using query and key, and then we convert the attention scores into probability distribution using softmax, and then we try to compute the weighted values, and then we add up the weighted values to compute the final output. Okay, last two steps 4 and 5 are kind of a bit tricky, so that is something that you need to understand properly. So here you can see carefully the score that was generated by q1 k1 is multiplied by v1. Okay, and then again q1 k2 is multiplied by v2, and q1 kn is multiplied by vn. So for the same query, the key for which it was multiplied, the score was generated, corresponding value is multiplied there. Okay, so that's how you get the weighted values. Okay, in the similar way, when we try to add up the weighted values, we need to be careful what values we need to add up. Okay, so in this case, see here we are adding the values corresponding to query 1. Okay, so all the values that are scored with query 1 will be add up to generate the first row in the output. Okay, and the same way all the values that are weighted with query 2 will be added up to generate the row 2. Okay, and so on. Okay, so this is something that you need to understand and be careful when you are doing the final implementation. Okay, so let us dive in and do the implementation. So I copied the um, weight matrices that we have used in the previous video to showcase the various steps of self-retention, so that we will verify like our implementation is correct to generate the final output. Okay, so let us start implementing. So here let us call our implementation class as self-attention. Okay, as usual we need to import nn module, this one, nn dot module, and as usual we will need to create first init, and we will need to pass embedding dimension, and let us call, so we need to pass embedding dimension as well as model dimension, let us call it, and also we need to call super so that it won't complain anything, and let us define self dot embedding dimension is equal to embedding dimension, and self dot model dimension is equal to model dimension. Okay, and now so as we have seen in the previous video that we need to create three linear layers, and we will follow the same concept. So we will say self dot to query. Okay, because we will use it to generate the query matrix. So let us call it nn dot linear, and input feature will be embedding dimension, and output feature will be model dimension. And for the time being, we will disable the bias, because we will use this model to generate the output that we have seen in the previous video, so that it will be consistent. Okay, so we will say the same as bias is equal to false, because we haven't used bias in our previous video. And similarly we will say to key, and similarly we will say to values. And that's all for this init method. So we have three linear layers that we will use to generate uh, query, key, and value matrices. Okay, and now let us implement our forward method, and that's where it will be a little important to focus. So we will say inputs, and so how we will generate query? Query is equal to self dot to query, and we pass the input, and that's all. We got the query, and similarly we will get the key, and similarly we will get the values. Okay, so we have created query, key, and value using input vectors. So okay, so we applied three different linear transformation on the input, and we got query, key, and values. Okay, so the next step is, let us comment it so that it will be much easier. So create query, key, and value using input vectors. Okay, and the next step is, what we will do is we will create attention scores. Okay, so compute attention scores. And how we will do it? We will simply multiply query with key transpose. Okay, so that is, we will call it attention scores is equal to, let us do math multiplication, and we will pass query and key transpose. Okay, and we got the attention scores. And the next step is we need to convert the attention score into probability distribution, and we will simply use softmax function there. So we will call it softmax, or let us call it softmax attention scores. Okay, and then what we will do is we simply pass it through the softmax function, and we need it to be on dimension -1, the last dimension. Okay, let us comment this as well. So we will call it convert attention scores into probability distributions. Okay, next is the tricky part. Now we have the tricky part is that we need to compute weighted values and add them up. Okay, so this is where we will use some operations. Mainly it will be like indexing and slicing. So I already created a video on that where you can learn it properly, like how we will do. So what we will do actually is we will reformat, or we will create a new view of the attention scores as well as the values, so that we should be able to simply multiply them and add them up easily. Okay, so we will simply use uh, slicing, and then we will simply add a new dimension in that. Okay, so what we will do is we will call it v formatted is equal to v, and we will simply use let us print it so that it will be much easier to view it. Okay, so let us print v formatted. Okay, and let us exit it. So let us create an instance of attention is equal to self attention, and the input dimension is 4, and the uh, hidden dimension we will use 3. Okay, and that's it. Now let us pass input to this so that it will run the forward pass. Okay, so let us run and see it. Okay, so it says math multiplication within one required argument. Let us see what is missing. Okay, so it should not be this, it should be this one. Okay, let us print v as well so that it will be much more clear. So if we will print here v, we will simply say print v, and let us see both of them, v and v formatted. Okay, okay, so what we have here is the actual v, and we have the formatted v, which is actually we change the view of it simply. Okay, so here you can see clearly that this row is converted into a matrix of 3 cross 1. So the none dimension is actually added one more axis to the row that it was traversing. Okay, and the same thing happens for row 2, which is value 2, and row 3, which is value 3. Okay, so this is simply like we created a new matrix for each value. Okay, and then let us do a formatting of scores as well so that it will be easier for us to multiply them. Okay, so we will use same trick with attention scores as well. So let us call it attention scores formatted is equal to, first we need to transpose it so that it will be consistent with multiplication. So let us call it transpose, and simply let us call t on it. It will be transposed. And next is we will simply do attention score formatted is equal to, we will simply run the same slicing. So this is first one, this is the second one, and this is the new dimension added. Okay, so let us print this as well and see. Let us rerun and see it. Okay, so now see it carefully what is happening here. So this should be q1 k1. Okay, this should be q2 k1, and this should be q3 k1. Okay, so what will happen is when we do a simple matrix multiplication, not matrix multiplication, it's simple pointwise multiplication. So this matrix will be broadcasted, and this v1 will be multiplied with all these three values. Okay, so this is q1 k1, q2 k1, and q3 k1. Okay, that's what it should be. Okay, so then when we multiply it with v1, we will get a new matrix which will be q1 k1 v1, q1 q2 k1 v1, q3 k1, and v1. This will be the multiplied values are weighted values. The same thing, the second matrix will be q1 k2, and this one will be q2 k2, and this will be q3 k2. And the same thing will happen when we will simply do a multiplication. This v2 will be multiplied with these three values because it will be broadcasted, and we will get here q1 k2 v2, and again q2 k2 v2, and here we will get q3 k2 v2. Okay, and the same thing will happen with this third row or the third matrix. This is nothing but uh, q1 k3, q2 k3, and q3 k3, and we need to multiply this with v3. Okay, so let us do that as well. So that should be clear. If you have queries, ask in the comment section. I will try to elaborate it further. So let us simply do weighted v, call it v weighted, is equal to, we will simply multiply this with v formatted. Okay, and the final output would be simply dot sum at dimension is equal to 0. So what we will do is, let us print weighted v as well, then we will do the final thing. Print v weighted. Okay, let us exit here and then read and see the output. So this one is q1 k1 v1, q2 k1 v1, and this is q3 k1 v1. Okay, and this is q2 k2 v2. Sorry, this is q1 k2 v2, q2 k2 v2, and this is q3 k2 v2. Okay, so this is like for q1 q2 q3 and corresponding keys and values. Okay, so the sum should be, this row is summed with this row and with this row. Okay, that's what the scores are multiplied for corresponding query. Okay, so the query one for all the keys and all the values are summed up. Okay, so that's what we will do in sum values. So we don't need this one. So that's what we did. We did it in dimension 0, and that's what is the final output. Print out. So let us remove this and run and see it. So this is our final output, which is coming for the input. When we pass it through the self attention, this is what we get. Now let us verify it replacing the weight matrices of query, key and value, so that it will be consistent with what we were getting in the previous video. Okay, so what we will simply do is self dot to query dot weight is equal to nn dot parameter, and we will simply pass w query dot transpose. Okay, and the same thing we will do for where key as well. So w key transpose, and we will get the new weights, and the same thing we will do for values as well. Yes, so let us do that as well. W values. Okay, so let us run and see that if we are getting the same output as we have been getting with the previous computation in the last video. Okay, so let us run and see it. So here you can see like we are getting 1.91, 3.24, 3.57, and so on. And if we look at our PPTs, and the final output was 1.9, 3.3, and 3.6. And then if we simply do a round of these values, we will get exactly the same output. Okay, so this is 244, 244, 1.9, 3.24, 3.57. Okay, so I hope that is clear. If you have further questions, ask in the comment section. I will try to address them definitely. So this is for a single input. Another case would be when we have more than one input sequences. Okay, like that is the case when we have batch of input sequences. Then how we apply the self attention, that we will see in the next video. And then further on we will learn about multi-headed attention definitely in the next video. So in this video we will stop here. In the next video we will continue learning self attention for batched input. So thanks for watching. Bye for now. Take care. See you in the next.